Today is my turn to be in charge of the presentation. As you remember, Beth had been talking to you about different components and the philosophy behind Atlantis, and now it's my turn to talk about the tools that we are using to calibrate and to build an Atlantis model. So why, the first question that you can ask yourself is why we need those tools, and maybe by intuition or because you put a little bit of attention to what Beth was saying, an Atlantis model is a huge monster and is using a huge amount of data. The configuration files are very, very big. There is huge forcing files, and sometimes depending on the type of simulation that you are doing, the output can be also very big files. Yeah. Now, the output of Atlantis, they have different level of complexity. You can use the normal TXT files, or also you can use a little bit files a little bit more complex in terms of the structure, like the netcdf files. And other problem that you have or you will face if you are building an Atlantis model is usually when you are calibrating, or even when you are building a model, is very time consuming. So it's not just me, or it's been a bunch of people that is been facing this problem before, and to help the community, they start building different tools to help in the different steps that you have when you are building an Atlantis model. So what tool do we have so far? Well, I will talk especially about two of them. One is called Linear Atlantis. That is a tool that it was developed as Shane Richard, that was working with us, and I've been in charge of debugging part of it, but he built that tool, and I just debug a little bit some issues related with that tool. And the other one is Reactive Atlantis, and that tool, I created that tool, and I created during my PhD. But saying that, if we come back to the Confluence page, you can see that in the Atlantis helper tool, you will find different type of tools, and all of them are related with different areas of Atlantis. Yeah, for example, we have the R4 Atlantis. That is another tool that is hosted in GitHub, and I don't know if it's been updated recently, but it's also very, very useful. You have tools that are connected, or they are being used for the model construction. Technically, they are very useful tools, but some of them, they are not being maintained by anybody. I'm being in charge of maintaining the CDF distiler, which is a tool that you can use to use one of the output of Atlantis and cut the output in a specific time, and use that new netcdf file as the new initial condition. So technically what it's doing is using the output to create a new input. Yeah, that is in that way you save time. You don't need to run the model every time to reach equilibrium, so you can use the model start from equilibrium. Yeah, and the other one is the hydro construct. That is a tool that's been developed by Beth, and both of them are written in C, the CDF distiller and the hydro construct. And those one, what they are doing is just the hydro construct is transforming the netcdf file and checking the netcdf file and creating the hydro files for Atlantis. Yeah, and then you have different tools that they are doing different tasks, no? And then you have R script that people decide to share with us, which is quite nice. And Then you have Python as well. Some tools are written in Python, and yeah. So technically, you will have quite a few tools here, and most of them they're doing different stuff and stuff that they're very useful. So if at some point you want to check if there is something that you need to do, maybe someone already did it, and you just need to explore a little bit the tools that we have here, and maybe you can get, maybe they don't have exactly what you need, but they can give you an idea of what you need to do. Yeah, so it's very useful to check this page. Now I will come back to the presentation. So there it is. So even if we have all those tools, I've been focusing my effort in those two tools that we have here, no, the Shiny Atlantis and the Reactive Atlantis. So how those tools works and what is the idea behind those one? So the main idea, at least for the Reactive Atlantis, was that I am a little bit impatient, so technically I cannot really wait for a long time to check, and also I don't want to repeat to do exactly the same hundreds of times, or like a copy and paste from a TXT file, or doing processes like that. It's tiring for me, so the idea is create a tool that is just reading directly the output, and then I can do analysis on those one, but also I need to be fast. So the idea behind this reactive approach is like you avoid data overload. That is something very easily to do in Atlantis, especially because you have output that can be close to 1 gigabyte. And even though I love R is not really efficient dealing with big size data. It's not like Python or C, yeah. And also need something that need to be fast in execution. R also is quite good to run a fast program. The function can be really fast, but the problem is like you have certain limitations. No, it's not like C that it should be a little bit more faster, yeah. But doing this reactive programming approach, and what the idea is, you don't load all the information, you just call the information when you need it, yeah, and then you can come back and trying to iterate between the information that you have, the input and the output, based on the needs in your needs, yeah. So technically it's just a visualization tool when you are doing a processing behind, and this processing is connected all the time with the output, yeah. Now you have different options for that. You can have just the visualization, or you can take the visualization, do some modifications to the files, and then get an output that you can use in Atlantis, back in Atlantis, yeah. So that was my idea behind when I created the Reactive Atlantis, and it's something very similar to what Chain did when he created the Shiny Atlantis. So the Shiny Atlantis right now is being updated, so all it will run with the new parameter files, yeah. So they have oceanographic forcing file, you have initial condition files, feeding and growth, biology parameter files. So technically the Shiny Atlantis, the Shiny Atlantis, is a tool that's being built to work with the input that you are using for Atlantis. And it's very useful not only to build an Atlantis model, it's also really good to check existing Atlantis model. It's really easy to use this tool, and also it's really, using this tool is very easy to pick up any issue that you have in the model, yeah. Yeah, so I will go through these two tools, and then I will come back and I will try to run each one of those with the CTAS model, yeah. So now going to the Reactive Atlantis, and my idea was, as I said before, trying to use a tool that is fast for calibrating Atlantis, yeah. I create that one during my PhD, as I say, and so organically it create based on my needs. Yeah. So what I need is this, and I was creating this tool for that specific task. I never thought in creating something that other people will use. After maybe a year in my PhD, one of my colleagues and a friend asked me why you don't share this one, and was like, okay, that is a very good idea. We should share the Reactive Atlantis with other people to use. So, but even though at that time was already a year or two, almost 2 years in my PhD, so I didn't have really time to think in the structure of this Reactive Atlantis. In the last year, I've been working in trying to give a more a structure that makes sense for the people that need to use Atlantis. Yeah. So to be clear, to understand what the people need, I did a survey maybe a year ago, and is the main result that I have from that one is like in terms of the general questions, like most of the people is working with R, which simplify the thing for me. People want the output not only in the reactive approach, it's also want the output in PDF, and yeah. People, the output that they want to look at are the size structure, especially with the species, yeah, and also something I realize that. Sorry, sorry, it's a misinterpretation here. What I wanted to say is like 60% of the people that is using Atlantis or that answer the survey look at the size structure of the species. And only 31% of those people are looking to the spatial structure of the system, which is for me was like a warning flag. No, is people Atlantis, one of the strongest how you say, part of the philosophy that is behind Atlantis is like a model that is working in the space dimension, no? So it's something that we need to look at. So it happened to me looking at few models that sometimes you have concentration of species in just one polygon. Technically, at the level of ecosystem, you can see that the biomass is going good, but the level of space, there's been just concentrated in just 1 or 2 polygons. So that made me think that one of the tools that we need to create is need to be based on looking at the data at the level of polygons. Yeah. So now in terms of the tools and questions, most of the people want the tools being focused in the calibration of Atlantis. They want tools that 50% of them want tools that implement the early warning approach. So that means that before you even run the Atlantis, you will have some areas or some warning saying, okay, it's very likely that the model will crash or you will have this problem because of that combination of parameters. Yeah. They want tools that they are focusing mainly in the predator and prey dynamics. Almost 90% of the people that answered the survey. Also, is 80% of the people is interested in the model skill assessment. So it's trying to, this model skill assessment is to measure how good the model is representing the dynamic of the real system. Yeah, and also people want to see if we can, those tools can be used to calculate some ecosystem indicators. And also we got some suggestions. People want specific focus in the calibration of the key parameters. If you have tools that there can help with that. And also there's quite a few people or groups around the world that they are working right now trying to use machine learning with Atlantis, which I think is is great, and it's also caught my attention. So I've been giving a thought about that, and Beth as well, I think. So yeah, so this, based on that survey, I decided to do some updates to the tool that I have. So the tool that I create, the Reactive Atlantis, they have some general updates and tool updates. And yesterday I did an update of this version number 2 of the Reactive Atlantis. So technically what I did is like an optimization of the code, yeah, and increase some new analysis like a mortality analysis. And now I want to create a tool of visualization for the spatial distribution of a species. Still in the kitchen, the network analysis, the early warning approach, the ecosystem indicators, and the PDF output. But so far, compared with the previous version, is 1,000 times faster. Just modifying a little bit the code. It's almost ready to be a proper cramp packages. Figures are more readable. Most of them. There's some of them that they have some issues. It's colorblind friendly, which some user asked me for that, and the upcoming tools are just focusing in what users or the community needs. Yeah. So what I will do now, it's a very short presentation about the tools and the philosophy behind the tools, yeah, and also about what is coming. Yeah. So the idea behind the tools obviously is just people to be able to use Atlantis, but at the same time to enhance engagement and collaboration between the different groups that they are working with Atlantis. Yeah. So now I will go to our studio, and I think most of you already download the Reactive and the Shiny Atlantis. So those tools are already in GitHub, yeah, and you can download at any time. You can directly download the tool directly to your R packages, like an R package to your library, or you can clone the repository and work on the code. Yeah. You can do both of them, which is, I think, you think is more suitable for you. Yeah, you have the Reactive Atlantis as well. Yeah, and you can see a few hours ago I did the last update. Yeah. So I will follow the instructions that I have here, and with the new model that we have now, the CITAS model. Something that I want to encourage people is, if you use the tool, the way that we can, if you want to modify the code, it will be great for us. But also, if you don't feel confident modifying the code and doing a commit, or I will encourage you to do, if you have problems, to raise some issues in GitHub. In that way, we can have priority, and it's relatively easy to do. And it's very straightforward to do. So if you go, for example, to this the Reactive Atlantis, if you go to issues, you can put new issue, and you can for example decide this is a bug and leave a comment for that one. Like, for example, the pipray matrix is not working, and then here you can post some R output mistakes. You just copy and paste for what you have from R, and then just submit the issue, and I will receive that one, and I will try to work as soon as I can and trying to help you to fix that bug. Yeah. So if you don't feel confident modifying the code, just put an issue there, and then I will try to fix it as soon as possible. Yeah. So yeah, with that out of the way, I will come back to the R, and I will start with the Shiny Atlantis. So the Shiny Atlantis, as I say, is focusing mainly in the input. So the first that we will use is trying to run the chain Atlantis to look for the VGM file. So we'll do an analysis of the VGM file of this model. Yeah. So as you can see here, it's just the VGM file. So it's calculating the volume, the depth for each of those boxes, is telling you if it's an island or not, and the area associated with those one, the number of boxes, and yeah, you can add some boxes or modify a little bit what you have here, no? But this is relatively easy to do and to check if you have any issue with the VGM file. Yeah, that is the first one. The second one, and I said is quite useful, is just to check the biological parameter file. Yeah, that will take a little bit more time because it's doing quite a few analyses behind the curtain. But when we finish that one, you will see that it's very useful, and usually you can run that one. Maybe you will run it once or twice. Yeah, but it's really good for people that is creating new models, and also for people that is start working with models that they are being created. Yeah, something that why I say that it's good to do. I'm been working with quite a few different Atlantis model, and it's very easy to do to make mistakes. Yeah, so, and it's really easy for people that is not being working with the model realizing those mistakes. Yeah, so if you are starting to work with a new Atlantis model, it will be easy for you to pick up maybe some mistake related with the model that is already created. Yeah, so I will encourage people that look at these tools and check if there is something odd. Yeah, it takes a little bit of time, but it should be relatively fast. Yeah. Okay. Let's say here will take a few minutes. I hope it's a little bit shorter than that. So it's doing quite a few, running quite a few processes behind, and it should be okay. So after checking the shiny Atlantis, we should go and have a look to the reactive one. Yeah, so we will start checking the input. It's taking a little bit of time, but so far so good. So it looks like it's running properly. Okay, now extracting parameters. That's good. Distribution and information. Okay, there it is. So, okay, it's open this HTML output, and then you have the map. Yeah, you have the map, and then you have the groups. You have the information related with the. This is the CSV file, no? It's reading the CSV file that you have, and it's showing you the species that you have in the model. And as you see, there is quite a few species, 62 species, and a lot of them are off, so they are not being used in the model, but they can be used. Number of cohort. So I think Beth explained to you what is the meaning of each of those and the name of each of those columns. Yeah? So then you have the global parameters. So this is part of the PRM file, the biological parameter file. So you have the file, the names of the flag, or the name of the parameter, then the units associated with that one, the value, and then the suggested value is the values that is based on literature, or is the range of the value that you should use. Yeah, sometimes it's just as a reference. Sometimes value can be higher than one or lower than those ranges. Yeah. Then you have the group parameter file, the definition file. So you have information associated with the edge structure prey, for example. Yeah. And you can have a look to those parameters and check if the flag is on, for example, or what the model is doing. And then you have the values associated with those one. Yeah. For example, we can use the Weber-Thornton Holt alpha parameter. That's the stock recruitment. So you have some values of Weber-Thornton Holt, the alpha parameter, sorry, for the Weber-Thornton Holt, and then you have the Weber-Thornton Holt beta. So then here you have for this species, for the large fish, planktonic fish, I think. Yeah, yes, planktonic large fish. You have the value of alpha and beta, and he's using a Weber-Thornton Holt recruitment function. Yeah. And so yeah, you have those parameters, and then you have the habitat and what type of habitat the species prefer, and you can have a look to those one. Yeah. Then you have the distribution, the spatial distribution for some species. Yeah, this is for a species that you don't have a spatial distribution. This is using the initial condition file. So, but if we use what the species they were on, come back here. FPS. FPS is one of the species that is being on. No? So we won't come back to FPS. We should have information of a spatial distribution of FPS, and there it is. So you have, this is the adults and juveniles, and this is the spatial distribution. This is the vertical distribution. Yeah, and then you have the density of those species. So it's a coastal species, and this is the distribution of the recruitment, the vertical distribution of the recruitment, and if in case there is migration, but for this species there is not. So yeah, this is the spatial distribution for this species for the first quarter, and then you have maybe second quarter, yeah, in case of the distribution is changing through time during the year. No, now the feeding. So you have the clearance here. So the clearance is how much water the species, depends on the equation, but it can be how much water the species is clearing in one day. No, so it's the volume of water. It's the volume of water that is clearing per day. So then you have the value of clearance for all the species, and so then you can have a look if there is something weird here that I don't know, a value that is missing or a value that is too high. Yeah. Maximum growth rate, that is the MAM value. Yeah. Yeah, it's exactly the same that for clearance. You have the values here, and then you can check. Yeah, it's just to check if there is something odd. Yeah, this is the, sorry, that's the feeding, this is availability, that's the baseline. So again, I will use the FPS. So yeah, this is the, it's just based on the p-prey matrix. No, it's telling you if there is feeding on adult or not. If it's information like that, it's just based on the p-prey and the value of the p-prey. Yeah, for example, you have here the small planktonic fish. The juvenile is eating adult. The juvenile on adult of PS. Yeah. So there is not much information here, but what it's telling you is the p-prey relationship with some species with PS, PL. I think it's large phytoplankton, small phytoplankton. This is the small planktivorous fish, yeah? And this is the diet. Yeah. Yep. migration. Then you have migration. We don't have a species that are migrating here, so I will. There is two of them that they are migrating. As you can see here, is the seabirds. Yeah. So how they are leaving the model, and at age. Yeah. And then the whales as well. Yeah. So you have whales and seabirds that they are migrating in and out of the model. And the recruitment that is based on the structural and the reserve biomass or structural weight or nitrogen. So you have those values, and then he created this one to represent the relationship between those two. Yeah, for all the recruitment of for all the species. Yeah. So this is the shiny R Atlantis that is checking the parameter files. Yeah. So now I will try to check the initial condition file. Yeah. So this will take a little bit for the tool. Is doing some processing. This should be a little bit faster than the one before. So the idea behind this specific function is to be able to check the initial condition file, species distribution, tracers, all the components of the initial condition. It will take a little bit of time, but it should be relatively fast compared with the other one. There it is. Okay, so here you can see that you have the number of layers, the information about the type of cover that you have there, and if this canyon is soft surface, is reef, is flat, and the number of layers by box. Then you have information about the abiotic layers. Yeah, so you have information on sediment, canyon, flat, what is reef. Yeah, so you have information about the spatial distribution of that and the values associated with each one of those. So you can see the box number 9 is almost 90% is covered by reef. Yeah. Now you go to the abiotic, but in 3D. So you have the volume, some vertical fluxes, and the nitrogen. So this is you will have here this ammonia, dissolved organic nitrogen. So you have information about what it can be, those ones, when you have the information in the initial condition file. Yeah. So you have now the biotic in 2 dimensions, especially the one associated with the sediment. So you have benthic racers, yeah, all of them associated with the coast. Yeah, let's see if we have another species. You have seagrass as well. Yeah, seagrass cover. Now you have the 3D. This is the species that live in the water column. Yeah. So you have cephalopods. What is the one that I think was a small pelagic fish? No, that's one that we saw that was on. So you have the structural value, and then you have this is the nitrogen, the total nitrogen. So you have the NAMs, the reserve, and the structural. So what are the NAMs? The number of species, the abundance, and you can see that is associated with one of the boxes here, the middle boxes in the other one, and the numbers associated to those one. Yeah, you have all the species here that you have in the model. Then you have the nitrogen. So this one is it calculates the reserve and the structural nitrogen for each of those species based on the initial condition file. Yeah. So yeah, it looks relatively okay. except for the pelagic shark, something weird there, but I don't think that the species is on in the model. But usually you should expect something like that, no? That the bones are a little bit lighter compared with the total fat in the system, in the species. Yeah. Then you have the numbers. Those are the numbers at age or cohort. Yeah. You expect a distribution like that with big abundance at the beginning and then decreasing through the ages. Yeah. Yep, that will be this tool. The other one that we have here is, and is super useful, is for the hydrodynamic. Unfortunately, for this model, the hydrodynamic files are divided in hydrodynamic A, B, C for the fluxes, and there is just one for the temperature. So it is possible to merge those files and to have just one, but for simplicity, I am using the output from another model. This is an input from the North Sea model. Yeah, and should run the last bit now. This will take a little bit, especially because it's doing all the calculation for the hydro, and usually those files are quite big. No, it decided to do it faster than the other, which is good. So you have here this is the connections, yeah, between the boxes, and so it's the what boxes are connecting, yeah. Yes, it's just that information, just in case you have boxes that are not connecting with anything. And you can see here that those two boxes that they are not connected is because those one are islander. Yeah. Then you have the exchange, the row exchange, and it's by polygon and layer. So you have the layers here, and then you have the different polygons, and then you can see the plot. The focal plot can be, for example, number 5. So you have here that looking at the information from the box number 5, all the fluxes are going to the, I will put the IDs, is going to the, I think we can, there is. So from box number 5, it can go to number 6, 11, 10, and 9. Yeah. These are the raw values. So this is just from the point of view of the box number 5. It doesn't tell you all the connections that they are in number 5. Yeah. For example, what happened from number 4 and 5. So if we look at the all, and we come back to the, so I was looking at the row, and I will look at the all connections, and we come back to the number 5. We can see now that it's connected to the other boxes. Yeah. The problem is that the difference was that the information for that connection, it was in box number 4, not in box number 5. So you can see that from box number 5, you have a positive flux that is coming from the layer number, the second layer. Yeah. So it's a upwelling size water that is coming from the bottom going up, and then it's going to box number 4 and number 9. And then you have also water coming from box number 10, 11, and 6. No? Now, when you look at the horizontal fluxes, so this is the fluxes in the system. Yeah. And where the water is moving, and this is the time step, and you can see how the fluxes are changing by days. No. Yeah. And this is the vertical fluxes. So it's the, yeah, as his name says, it's the vertical fluxes. So you have water going up, for example, in blue, and water going down in orange, red. Yeah. You can plot the raw values, so then you can see the intensity of those fluxes. Now this is a little bit more complicated. No, it's not really complicated, but it takes a little bit more time because it depends on the hydrodynamic model. It can be a really large time series. But I will come back to box number 5 and I will enable the plotting. So that will take a little bit longer. Yeah. So bear with me. We should have a really nice plot eventually. And this is for the time series of fluxes, if I'm not wrong. Yep. So this is the exchange out from the focal box and layer. So this time will be from box number 5, layer number 1. So yeah, this have how many? Almost, I would say 10,000, I would say maybe 10,000 days. Yeah. So you have going to box 10, layer 1, 11, number 1, box number 2, layer 1. Yeah. So this is the information that you have here. And you can exclude the vertical, so you don't have the vertical fluxes, so just the horizontal fluxes. It will take a little bit longer as well. I shouldn't have done that, but I did it. So you can spend a lot of time here checking the hydrodynamic, and it's very, very useful. Yeah, it's a little bit difficult to see it here, especially because it's a very long time series, but there is something odd that you should be able to see it. So now the temperature, so you can see how the temperature in degrees Celsius for each of the boxes at the time step 0, yeah, and how it's changing through time. Yeah. Now if we go to the temporal variation of that one, then you can see that you have a seasonal variation. It's quite clear, and yeah, it's going almost for 10,000 days, sorry. Yeah, for each layer. So the box number 5, we should have something similar. Yeah, it doesn't change much for each layer. Box number 10, if we have any variation, not really. It's very similar between the boxes. Now we are going to the salinity. It's a very similar type of plot compared with the other one, and you have the time series as well, and you can go and check by boxes, like box number 5, and you see each time step and the changes. So this is very useful tool that you can use for the hydrodynamic of your model. Yeah, and this will be almost everything related with this tool, except one little bit that I think I talked yesterday during the Q&A session, and it's this last one here, this makeinit.nc. This little tool, what is it doing is taking is creating some CSV file that then you can populate with information, and using that information you can create the new initial condition file. So what Chain was doing here is trying to create a way to help other users to create their own initial condition file. Yep. It's quite nice because you can, yes, with a click, modify completely your new and create new initial conditions. So that was the Shiny R Atlantis. It's very useful. And now I will go to the Reactive Atlantis. So for the Reactive Atlantis, I will be sure that I am in the same directory. I think so, right? So I will call the library, so I will call the package from the library, and I will run. And this first one, what it's doing is a mix between input and output. So what it's doing is looking at the input and using the output at the same time to calculate some values. As I say at the beginning of the presentation, I am not really good at modifying files by hand, and usually I am really good making mistakes. So the idea behind this tool was for me to avoid that problem. So I want to have a tool that allow me to visualize the p-prime matrix. If I remember well, I think if you remember, the p-prime matrix is a huge matrix with numbers, yeah, that is used to show the relationship between the predators and the prey, especially between predators and prey, juveniles and adults. So it's a huge matrix, and it's really easy to make mistakes. So this tool, what it's doing is exactly that. It's checking at that information. So you have the availability matrix, that is the value that you have in that p-prey matrix. Then you have the effective predation. So what it's doing, that one is using the information from the gap limitation, and then using the initial biomass of the system is calculating how much predation you will have if the prey and the predator are in the same box at the same time. Yeah. Then you have the overlap matrix. So this one is just the gap overlap. So this means, is the prey small enough to be eaten by the predator? Or looking another way, is the mouth of the predator big enough to eat the prey? Yeah. So this one is looking at that information. Yeah. So far is the function that is using is the knife edge function for that, but it will be easy to just to modify that one, and that is one of the next update for this one. And the percentage of pressure is how much of your total biomass is being eaten if the prey and the predator are in exactly the same box and the same layer at the same time. Yeah. So you can see quite a few species that if they manage to be in the same time, at the same time, in the same box and the same layer, they will be eaten completely. Yeah. And this is information related with the total biomass of the juveniles and adult biomass. So the trick behind this one is, for example, if I am going to a small pelagic fish, yes, small pelagic fish, and this one I think it should be eating zooplankton. Yeah, zooplankton large, we'll see. Yep, there is. So 0.3 the value of, if you come back here, so it's at this value here. Yeah. That doesn't really help me much. It's just to visualize what it is. What is really useful from this tool is, like, you can add a new value to that one and change the value in the matrix. So now you will have a different value here. Yeah, or you can just simply put 0. No, you can put 0, and you will have 0 interaction between those two. And that is great, no? But the main still the problem, like, okay, I changed that in the Shiny app. And the next step after that, after you do all the modification that you have in the system for this p-prime matrix, then you can write this p-prime matrix. And if we are lucky enough, that will be written in the same folder. Bear with me that I don't know how to use this Mac. It should be around here. So there it is. So yeah, this is the new P-Prey matrix. So it makes the job for you. So you have now the new P-Prey matrix, and then you guys just copy and paste this new P-Prey matrix on Atlantis, and you will be sure that you didn't do any mistake. Yep. So to simplify your life, this new approach. Yeah. So this is quite useful, and I use quite a few times during the calibration process, especially to check if there, why it's not being eaten. So I'm trying to check if there is a P-Prey overlap in terms of the gape, or yeah, specifically if the term gape overlap. And now you have, I did 2 runs in this model, yeah, and I modify a little bit the MAM and clearance of few species. So Beth already showed this tool. What is doing this tool is comparing 2 different runs. It's very useful when you are doing calibration and you modify one of the one parameter and you want to see what is happening in the system. Yeah. It shouldn't take very long. There it is. So yeah, in the first part, just showing you what happened with the biomass of each species. Some of them are declining. So FPS, for example, is a little bit different there. So I changed the clearance of FBP. So I decreased this one 10 times. So you can see that is a change in the total biomass in the system, so for that species. But there is also an effect on a small pelagic fish. And not really much changes there. But yeah, this is a very useful tool to compare between 2 different runs. And then you have the relative change. The relative change compared with the initial value of biomass. Then you have at the level of the system, you have different functional groups, and then you have you can compare the different runs and for different functional groups, and then you have the values by reserve, structural, and numbers. This is I think Beth already talked about that, but it's good to say it again. Is looking just at the biomass, it can be tricky, because behind the biomass it happened to me during my PhD that I was just looking at the biomass and I was thinking like, oh, the biomass is going okay, but in reality I was having a huge number of individuals, but they were super skinny. Yeah. That was one of the issues. And the other one, with another species, the biomass was also going okay. The problem is like it was super fat, but maybe few individuals. I think was just 3 or 4 fishes that they were, each one of them was 1 ton each. So and technically those one were small pelagic fishes. So as you realize, it's a really good idea to look at the numbers and the structural and reserve nitrogen. Yeah. So this one is to compare between the different runs, different species. Yeah, if they are doing exactly the same, or if they are doing okay. Yeah. So you can check the numbers, the reserve nitrogen, structural. Yeah, it's quite useful for that. And then you can scale to 1 or just look at the real number. That is also an option for that. And you need to remove the limiting the axis. So yeah, and then you can compare if there is any big change for any of those time series. Now this one is just looking at the last run. It's not looking at both of them, just one, and it's looking by age class. Yeah. So it's checking, for example, for a small pelagic fish, it's checking the reserve, the structural, and the numbers, and the biomass. And this is quite good just to check what is happening in the system, if the numbers are going crazy, or if for example the reserve nitrogen is going very low, maybe is the growth rate is really small, or maybe they don't have enough prey, or the clearance is really low. So it's a lot of information here that it can help someone to calibrate an Atlantis model. Yeah, that is the compare tool. Then you have this grow pp, but what it's doing, this one is checking the primary producers. So what it's doing, this one is taking the growth rate and different components of the system, especially ammonia, nitrate. For diatoms, is also checking if you have a silicon dependent. So it's calculating the total growth, the effective total growth, if the species they have light limitation, or if they have nutrient limitation, and in some ecosystem also if you have an eddy scalar. Yeah. So for box number, I think number 1, for example. Okay, there it is. For box number 1, you have this macroalgae. You can see that macroalgae, the effective growth is not really that high. There is almost no limitation by nutrients, but there is quite a strong light limitation in the system. Yeah, and there is almost no effect of eddy. For seagrass, seagrass, the effective growth is following the light limitation. So for seagrass, the limitation is clearly by light. Yeah. For macroalgae, even though there is the growth is being limited by light, there is also an effect of it can be predation of mortality. Yeah. So then you have phytoplankton, large phytoplankton. So and by layers. So in layers in the sediment, you have large phytoplankton that they have a lot of nutrients, but it's not growing. And this one, it should be layer 4. There is a strong light limitation. Yeah, there is light limitation. The light is limiting the system, I think, for those species that is in box 1. This is the small phytoplankton and the seagrass. So yeah, there is the system is being limited by light. This one, what it's doing is it's very similar to the previous one, but it's comparing all the components all the plankton of the system, the zooplankton and phytoplankton. Yeah. Also, it's plotting light and eddy. This is very useful when you have the system that, for example, some primary producers are not growing, like algae or seagrass or large phytoplankton, and usually it can be related with shading, for example. That is one species that is growing too much in one of the boxes and is creating shade, or is being, for example, if the small phytoplankton is growing too much and the small phytoplankton is decreasing in the same box and same layer, maybe there is a strong interaction between those two. Yeah. So here I have, for example, the large zooplankton, and I will put the large phytoplankton in box number 1. Yeah, we were looking at that one. So you have in red is the large zooplankton and the medium zooplankton. That is strange. This shouldn't be that one. Okay. It's not changing for the box, not changing the values. That is something strange. So for the variables here, but the values are changing. So there is something related with the labels more than with the real value of in the plot. So small phytoplankton, seagrass, gelatinous zooplankton, medium. Yep. So what is doing this one is just checking if in any box and any layer you have the interaction is strong between those one, or there is light limitation. So if I'm going to look at light again, yeah. So yeah, it's quite useful, this tool, to check if you have any predation or shading issue in one specific box or layer. Yeah, I usually use this one to check if one of my primary producers is not growing. So the next tool that is called is the food web. So this one helps to visualize why sometimes where it goes. Okay, we'll run it again. There it is. So it helps to visualize the relationship between the predators and the prey. The big problem that usually I did have was to understand why, when I was increasing or decreasing the biomass of a specific predator, I was not seeing the effect I was expecting. And usually it's because the relationship between species is a little bit complex, as you see here. So increasing one doesn't mean the direct increasing in the other one. Maybe it will means that when you decrease the predation, the predatory pressure in a prey, what you are doing is just increasing the standing stock of the prey. Yeah, doesn't mean that it will increase, but it will be enough to be in the system or to be food for another predator. Yeah, so this food web was helping me to that. Also, it's calculating the trophic level for each of these species at each time step. It's based on very simple equation, and yeah, what it's doing is just calculating that trophic position based on what they eat and the amount that they're eating. The proportion is how much those one are just filters to filter how much information do I want to have to plot. So I just want the prey that represent the 10% of the total predation. More than that, I don't really care. The number of trophic connections has how deep, based on the focus functional group I want to go. I will, this one for example, there is none. Okay, there is not interaction between prey and predator for FPL. Cephalopod should go. Cephalopod, there it is. So cephalopods, I will increase a little bit them. So yeah, the cephalopods is eating a small pelagic fish and demersal fish, I think, the small demersal fish, and DR and DL. So yeah. And this is the trophic position, those one, based on those one. Then you can have the polygon or the food web by box. I didn't have that one for this specific example, but it's relatively easy how to obtain that one from Atlantis and then use it here, that txt file. Yeah. And the last one, I think, yes, the Max. No, Mac. No, Max, not Mac. This one is the predation interaction between species. And this one is doing is just that, looking at the level of predation through time. This is total biomass, and the relative biomass is very similar to the plot that we saw in the compare tool. Yeah, I just put it here because I don't want to run two different shiny apps just to see that. This is the predation through time. So this is a small pelagic fish, and you can see how the diet composition is changing through time. So the prey, it was a large phytoplankton, yeah, then you see how the small phytoplankton is increasing quite a lot. Yeah, and then you have labile detritus and refractory detritus as part of the diet as well. Yeah, and the main predator for a small pelagic fish are the cephalopods. Then you can have the total predation in terms of biomass, how much biomass is being removed. Yeah, it's quite a lot by cephalopods, by the way. Then you have the predation by age group. So as you remember, each age group have different from the pea prey, you can realize they have juveniles and adults, and those one they can have different preferences. So for the time step 1, a small pelagic fish is just eating detritus, and yeah, if you move through time, you will realize that how the diet is changing, and it's adults and juveniles in this model looks that they are eating exactly the same. Yeah, so they have exactly the same diet. I will check another one. So FBS, I don't know, there it is. So then you realize in the age 3 you have the diet is changing, so they start eating themselves. Yeah. And then you have, so this is giving you information about the difference in diet by age by each species. Then you have the biomass by age, but in terms of the total proportion, and on top here you have what is happening with the biomass of that specific prey at that specific time step. So if you, for example, at 500 time step, you realize, looking at the plot, that the small pelagic fish is eating a lot of small phytoplankton, and if you look at the plot on top, a small phytoplankton, the biomass is huge. Yeah, so technically, how much there is a lot in the system, so of course they are eating that one because it's easy for them to catch. And PL is also going up, and yep, so that is the information that you can get from this one. The last one, we don't have information for the time series of catch, but this one, what it's doing is looking at the information of catch and trying to do an skill assessment. So here is showing, for example, that from the 2000 is not having, there is not being fishing, and then you have a total of 3.5 tons of cephalopods that are being removed by the midwater cephalopod fishery. And then you have the numbers as well. FPS, I'm not really sure the FPS. So this one is how much is being removed in the system by age class. So if you have a selectivity curve inside Atlantis, you should have changes here. So this one looks like the fishing starts from age 2, and age 1 is not being part of the fishery. And the last part of this tool that is not running for this specific example is the skill assessment. So what is doing the skill assessment is just taking information from a time series of observed data and comparing that one with the Atlantis output, and it's calculating the skill at how good is Atlantis to represent those specific time series. Yeah, and those will be the two main tools that I'm been working with recently, and it's been for the Reactive Atlantis being an update a few hours ago, and it should be few updated coming soon as well. Yeah, and so yeah, thank you for joining me in this presentation, and I hope to see you during the Q&A session in maybe in few hours. All right, take care, see you soon.